Hi, everyone. Welcome to Milestone 4 of the Data and Research Methods Project, organized by the National Student Data Corps. My name is Lauren, and I am a member of the NSDC project team. In this video, I'm going to walk you through Milestone 4, which is found in document B of your project packet. I'm going to share my screen so we can read through it together. As you can see, milestone number 4, which is on the basics of data cleaning and prep, should take you about 5 hours to complete. Let's get started. It says, your colleague Matteo thinks that you're ready to begin learning about data analysis. Matteo is a data analyst, and he is scheduled a meeting with you to review the CDC dataset that you will be working with. Matteo shares 2 files with you for milestone number 4, which are linked right here. Milestone 4 data is an Excel file which contains a main tab, which is called data, and 4 other tabs which provide examples for other tasks that we're going to tackle later in milestones 4 and 5. The data dictionary, which is the second file, that should only have 1 tab. Note that these links here will take you to read-only copies of those files. You're going to need to download them in order to begin your work. You can then either access the data using Microsoft Excel or Google Docs, depending on whatever you prefer. Just to note that the data may load a little bit slower in Google. Okay, so I'm going to pause the video now, take a minute to download these files and open them in your preferred program. Come back when you're ready to move on. Welcome back, everyone, to milestone 4. You should now have these 2 files opened, milestone 4 data and the data dictionary. Let's take a look at what to do next in task 6, which is about getting familiar with the data dictionary. So it says, Matteo has taken the raw data from the CDC and transformed it into an understandable and workable document for your analysis. A data dictionary is a list of the names, definitions, and attributes and questions associated with each survey entry. And so we're going to find a bit more information about the data dictionary using those links that are provided here in this paragraph. So there are a couple of things to note at this point, namely that Matteo has done some great pre-work for you all in putting together a clean and accessible data spreadsheet and data dictionary for you. So I'm going to read through the bullets that are provided right here in your document B. I'm going to share with you exactly what I mean when we've written out all these points. So number 1, Matteo has color-coded the data so that the columns are grouped together by subject. So for example, you'll see that columns B through Q, highlighted in orange, all relate to demographics. So right here, B all the way over through Q, demographics. Similarly, we have columns R through W. These all relate to employment. These questions, right, correspond with each of the columns that are also color coordinated in your data dictionary. So for example, you'll see that ESTST, which is column B in their data sheet, corresponds to question number 1, row number 5 here in your data dictionary. So ESTST is again the variable, and this is a list of all the possible answers to that column. These are the list of possible values in column D. So we know, for example, from looking at this, anybody who lives in, let's say, the state of New Mexico will have the value number 35 listed in column B. So let's go back over here. All right, so to give you an example, I'll go all the way to the top. Our first person is in state number 34. State number 34 is New Jersey. Okay, so we have a resident of New Jersey. The reason that you're going to see this value number rather than the words with string New Mexico, New Jersey, Kansas is because the data sheet is not coded. And I've provided information in your document about what data coding actually means. We'll get into that as well in a little bit further down in this milestone, but essentially this is because of the way that the survey itself was built and designed. The computer assigns a numeric value rather than a string to that respondent's answer, okay? So it makes it easy for the computer to process. It means that we as the data analysts need to spend a little bit of time understanding the data dictionary and using it like a key to understand this milestone data, okay? All right, another point to note here, Mateo's data set is a shortened version of that full CDC survey that you looked at in the previous milestone. It doesn't have all the questions that were possible. This was done to make the analysis process much easier for you. For example, we've removed survey data that's not really related to this project on remote work. So things like natural disaster preparedness was removed because that's not really strictly applicable. This was done just to simplify your analysis. If you scroll through here, you'll see there are a ton of questions about everything from housing to food security, utilities, employment. I'm not worried about you having enough to work with. I think this is plenty. Okay, another thing to note is that we have removed, or rather Mateo, right, has removed entries where the participants declined to provide responses to more than one or more questions in the survey. So for example, if this first participant right here declined to indicate in column Q what their income was, we removed that individual from the survey. This is really just done to keep you from having to decide what to do with missing values. This is why we had you learn about different kinds of bias in milestone 3. Here, right, we're pretending that your team has already started to make choices that are going to impact the outcomes of your research. Again, that was done simply to make things easier for you. Does it mean that there will be some kind of inherent bias, right, respondent's bias in your final analysis? Yes. But just for the purposes of learning in this project, that's what we've done here. Okay, final small thing to note. Column D, region, is blank. We will get to that in a bit. Don't worry about that column for now. What you should do at this stage is just explore the data dictionary, spend a bit of time looking at the data set to really get familiar with the types of data that are available to you from this broader survey. Okay, so just explore, get a little familiar with things. I'm going to pause the video again so you can do that kind of research. Think about what is available to you, and I would say spend maybe 10 minutes doing this, and we'll begin the formal analysis shortly. This is just you getting familiar with the formatting and the relationship between your data and the dictionary. So come back here when you're ready to move on. Hi, everyone. Welcome back to milestone number 4. At this point, you should have your 2 data files open, and you should have spent a little bit of time exploring those spreadsheets. What we're going to do now is dive into this process of data pre-processing. So first, and really importantly, we are going to save a clean original copy of our spreadsheet. Before you make any major changes to your work at any stage going forward, make sure that you have a copy saved as a backup. It's really easy to make mistakes, even when you're an expert. Make sure that you have a clean copy in case you ever need to backtrack or start over. It's better to be safe than sorry. Do not skip this step. Okay, so on to the fun stuff. We're going to be talking in the next few minutes about how to manage basic data analysis in Google Sheets or Excel. We're going to be talking about shortcuts, filters, sorting, search and replace, conditional formatting, essential formulas, including sums, concatenations, averages, counts, and trims. I hope you're excited. We have provided a handful of resources for you in document B right here that will help you if you need additional support with these basic concepts. For now, what I'm actually going to do is walk you through the basics in my own Excel spreadsheet that will act as a demo for you. Once you understand these basic concepts, it will be much easier for you to apply these tricks in this milestone as well as future ones. So we're going to be using this demo to walk through some of the basic key formulas. All right. So this is a made-up spreadsheet. You do not have a copy of this data sheet, but this is just a simple demo for you for some basic concepts. You may recognize a handful of these columns from your own data sheet. This is really just the first few columns of the Milestone 4 data set that you've been already looking at. As you can see, I'm working in Google Sheets, but you can definitely do this in Excel. So let's start with some basic shortcuts. This will help you if you've never worked with spreadsheets before. So let's go at the very, very beginning. Let's say that I'm working in my document and I typed something by mistake. I don't mean to, but oops, I wrote hello. I overwrote the text that was here before. If you want to undo something that you've just done, you're going to want to press Control Z. It's quick undo. For Macs, I believe it's Command Z. If you want to, let's say I want to undo what I've just done, then I'm going to press Control Y or Command Y for a Mac. So it's undo and redo. Really simple, really easy, but if you've never worked with it before, this will save you so much time. Okay, something a little bit more challenging perhaps. Another shortcut that I use all the time when I'm working in Excel is actually Shift, Control, and then an arrow key. So what this does is it lets me highlight all of the adjacent cells. So here I was in EST, ST, Shift, Control, down arrow key, it highlights the whole column. If I want to highlight everything to the right, Shift, Control, to the right. Easy. Really will save you a lot of time, especially when you're working with a large data set. So for Macs, that would be Command, Control, and your arrow key. Super helpful when you're trying to highlight a lot of cells at once. All right, so again, there are some additional shortcuts that we could be talking about. If you wanted to learn more, you can go back to document B. There is a link in that document to some additional shortcuts. All right, the next thing I want to show you is search and replace. The quick shortcut for search is Control or Command F, right? And then you have a little pop-up. We can, for example, search for all the years 1950. It'll highlight those two 1950s for us. The more advanced version of this is actually replace, not just search, but replace. That shortcut is Control H. Wow, so okay, we have a lot more options here. Let's say that we want to not only find, but also replace everybody whose data says that they were born in the year 1955. Maybe we want to replace it with the term hello. Okay, so we've put in here, find 1955, replace with hello. Then there are a couple options down here that we want to consider. First, make sure that you're only going to be working in one sheet, either this sheet that you're currently in, or in this case, if we have an extra tab, as an example, that you don't want to apply that search and replace to all of the sheets. Okay. Then you want to say, am I mashing the entire cell content, or am I just replacing part of a text string? So this would be important, for example, if we wanted to do a search and replace for 1955 right here. See, 1955 is at the very end of cell A9. So we wouldn't want to accidentally put hello there. Here, I'll show you. So, all right. So now I accidentally have hello right there. I don't want that. I just wanted to replace these two. So when you are doing a search and replace, just make sure that you're checking out all of the different boxes here. If you wanted to search within a specific range, you can also indicate that to say like, actually, all I really want is to highlight column E through E. And it'll only look at the values of E. So there's a couple ways to restrict, but that search and replace function is going to be super helpful for you when we start to do some of the data coding that we were talking about earlier. Okay. The next thing to talk about here is filters and sorting. If you aren't aware of what a filter or a sort is, I'm going to revolutionize your life right now. So obviously here we have a couple columns about demographics. What if we only want to see in our view people who live in the state number 13? So what I would do is I would add a filter. So I'm going to highlight what essentially is going to be the top of my columns. And I'm going to go into options and press this little button that kind of looks like a funnel. I'm going to create a filter. What this does is this ensures that row 2 is now like the top row. When I click on, for example, because we were just talking about states, let's look at this little funnel for column B. A window pops up and I can now see down here all the different values that are in that column. If I only want to see 13, clear, select, or I could type 13, and now only 13s appear. This is a really quick way to review a lot of data when there are many, many, many options within that column, just like state, right? I'm gonna Control Z to undo that work. The other thing that you can do with a filter, let's go back to this, is I can choose to sort that column. So right now, everything is kind of in a mismatched order. If I want to do sort A to Z or smallest to largest, now all of my states are in order. It's just kind of another helpful way for you to very quickly see information. This is a super helpful tool, and you're going to use this sort filter feature to do some additional data cleaning in task 8. So keep this particular shortcut in mind. The next thing I want to show you is called conditional formatting. This is a great way to organize our data so that the visual appearance of our cells is managed by the content of the cell itself. So normally we would only apply colors to our cells to make the data easier to review. I don't know about you, I'm a very visual person, so having color-coded things makes it much easier for me to manage. Okay, so let's take as an example this birth year column. I'm gonna click at the top and highlight column E. Then what I'm going to do is go to Format and Conditional Formatting. And then this box opens up on the side over here. Let's navigate to Color Scale. What that does is it's going to automatically understand the range of dates in these fields and assign a color scheme to them so that the larger values get darker. You can adjust some of these settings in here to decide like what is the midpoint color, what is the max and min value if you want to exclude outliers. Basically, this is just a quick way to see where are the biggest values in a given range. So keep this in mind. This is a really nice, not data visualization, but it's a really useful tool for exploring data in a very quick way. We are going to get more into conditional formatting in task number 7, so keep this in mind. Next, we're going to take a look at some key formulas in Excel and Google Sheets. This will help you do some essential editing in your document. I've included back in document B a list of some key formulas that you're going to want to know when working in Excel and Google Sheets. We're going to learn about these formulas first by just like clicking through. Go ahead and read some of these materials here. I've also created for you, as you can see, tab 2 of your Milestone data to see some demos of those formulas. So if we go back to our Milestone 4 data, you should all have access to this. Second tab right here, key formulas, just gives you a demo of how some of these formulas actually work. So we'll talk about sums, averages, counts, countifs, concatenates, and trims. You're going to want to read those resources that I provided, and this is a good example of how all the formulas work. You can mess around with the formulas, which are shown over here in real time, adjust things like that to get a better sense of like what the data does when you adjust the formula. So review all this material, experiment a bit with your own shortcuts and formulas. You can start looking at how this would impact the work that you do in your main data sheet, as long as you've saved a copy, right? So take some time to look at all of this material. When you're ready, come back and we're going to switch gears a little bit and start talking about data cleaning in task number 7. See you in a bit. Hi, everyone. Welcome back to milestone number 4. At this point, you should know the very basic essentials of navigating Excel or Google Sheets. And so we're going to switch gears to start talking about deduplicating the data in task number 7. So we, in this task, are going to be deduplicating information from column A, which is the participant ID numbers column. I'll show you right here. It's this section. We are only going to be deduplicating column A at this time. Again, make sure that you have a blank copy of your work saved before you do anything. All right, so now there are 2 ways that we can deduplicate data. The first option you should be a little bit familiar with already. If you've read the materials that were provided in just the section above, right here, on conditional formatting, you're going to know exactly how you can use conditional formatting to remove and identify duplicates. The second option, you can read through this here, especially in Google Sheets. This is pretty simple. You can do what is called like a data cleanup shortcut. When you do this, make sure that you're selecting all the columns for analysis, or what the program will do is just remove the duplicates from that column set, leaving you with like uncompleted rows on the other side. Take a look at these instructions. I'm going to let you go back to the conditional formatting notes if you need a refresher. I'm going to pause the video here, work on task number 7, and come back when you're done with the deduplicating and get ready for task number 8, when we will prepare our data. Okay, everyone, welcome back to milestone number 4. At this point, you should have just completed task number 7, and we're going to move on together to task number 8, where we are preparing our data. It says here, Mateo has started the data preparation process for you. Earlier today, he began to replace values in column C. So let's take a look. In column C, if we look here in our filter and scroll down, oh yeah, he did. So already you can see some of these numbers, which represent different metropolitan areas, have been partially changed to represent like the actual metro area, Los Angeles, Miami, Phoenix. Okay, so he started to do the work, but not all of this has been completely done yet. Okay. Pick up where he left off and do a search and replace for each of the values in this column, so column C. This is what we were talking about before. This is called data coding. What you'll need to do is refer to the data dictionary. Let's go to our data dictionary. I'm going to go down to this metropolitan area right here. You can see these are all the possible values in that column. They could be blank, meaning that that person doesn't live in a metro area, but if they do, this is how it'll be coded. So you're going to want to find and replace everything with this string of numbers and put there instead this string of letters. Okay, refer to the data dictionary to find that text string and do a search and replace. We already talked a little bit about how to do a search and replace. If you need a refresher, here's some instructions on how to restrict those columns so that you're only searching and replacing in that specific column. When you have done this process for column C, I want you to go ahead and complete that process for also columns B, G, and H. Spend a little bit of time on this. I'm going to pause the video again so you can work on task number 8. Come back when you're ready to do task number 9. Hi, everyone. Welcome to milestone 4. We are just finishing up task number 8, and we're now going to move on to number 9, where we are handling inconsistent data. Okay, so you will notice in column E, so let's go look at column E, right here, T birth year, that there is some inconsistency in the data. Most of the entries provide only the year for the birth of the respondent, but a handful include the month of birth as well. So let's take a look. We look at our search filter, we go all the way to the bottom. Oh yeah, so see, some of these 1954-3, so this person was born in March of 1954. This one, September 1959. So what we're gonna need to do here is find these inconsistent entries. The birth of month or the month of birth data is not helpful for us here. This is the result of what we consider a collection error. To remove these, what we can do is actually filter the column the way we were talking about before by showing the small or the largest to the smallest value. So we're going to do Z to A. It'll take a minute because it's a big data file. Great. So now you see here at the top all of these entries. We're going to fix those inconsistent entries, remove the birth months. Okay, so I'm going to pause the video again so you can work on this task number 9. Come back when you're ready for a demo of recognizing outliers. We'll see you in a minute. Hi, everyone. Welcome back to milestone number 4. You should have just finished task number 9. And so now we're going to sit down and talk for just a minute about outliers. So there are a handful of spaces in our data set where we can see outliers. Outliers are essentially any data point that is extremely high or extremely low relative to the median. And the importance of this is that with outliers, we're running the risk of having a very skewed analysis. They can overweigh our analysis in one direction or in the other. So to see an example of this, let's take a look at column L. We're going to go over here to column L. Okay. This column represents the total size of the respondent's household. So you can see here 3, 5, 2, 1. This is the number of people in that household. If we sort this column by size, I'm going to do it from largest to smallest, we're going to see in the results that there are a really small number of households that have 8 or more residents. So you can see here, so this is 10, it's a big house. And as we scroll down, this is all of the households here that are 8 people or more. The total count of the cells that I've selected here is 50. So just 50 of our total 10,136 respondents, which is about 0.5%, have 8 or more residents. So we're not going to do anything with that information at this time. It's just important to know that this small number of individual households is really outside that normal range. The reason this might be important is if we compare, for example, the responses of this subgroup of 50 households to others in this larger data set, if we compare their responses to, say, the answers that we would see in column BR, hold on, just scroll over, BR, which is a set of responses to this question, and you can look this up in your data dictionary. In the last 7 days, how difficult has it been for your household to pay usual expenses? So what we might expect to see is that families with 8 or more members would have more difficulty affording household expenses. And we do actually see that. If you compare the data in this sheet, right? Those families, those 50 families with 8 or more people in them, had an average score in this column of 2.5, which is higher, right, than the overall average, which is 1.9. So this is just an example, right, of how an outlier subset can really impact the overall averages of your spreadsheet. That makes total sense. When this survey was done in the late summer of 2024 through the early fall, a lot of people were talking about the rise in food prices in the United States. So it makes complete sense that a group of individuals who have large families would need to have more money on hand in order to pay to make sure that everyone had enough food to go around. So it makes perfect sense given the time of the survey. The point here is not necessarily to make any given point, just to let you become aware that outliers can really skew your data. In fact, I would say that some analysts, especially in machine learning or AI, will use a process called smoothing to remove outliers and then make the patterns underneath them a little bit more visible. So the point here is, remember to check for outliers when you're reviewing your data. I'm going to pause this video now so that you can read back through some of this other material. Up next is actually task number 10, which is supplementing the data. I'm actually going to pause this video. What is going to happen next is we're going to have our first mini lesson of the DRM project. You're going to hear from another member of the NSDC project team, Emily, who's going to help you work through task number 10. She's going to talk to you about supplementing your data, putting new information into your data set. She'll work with you on task number 10. Watch her DRM mini lesson. Come back here when you're done.
Hello, everyone. My name is Emily Rothenberg, and I'm the Program Manager of the National Student Data Corps. Welcome to this quick tutorial on Excel's if function. If you're just starting with Excel or need a refresher, this video will help you understand how these powerful tools can make your data work for you. Let's start with the basic if function. An if function checks if a condition is true or false. It will return one value if your condition is true, and another value if your condition is false. For example, if someone's test grade is greater than 65, we want to consider that a passing grade. If it's not greater than 65, then we want it to be considered a failing grade. We're looking at just two options here, pass or fail, so we can use an if function. Let's type one together. First, we'll start with an equal sign and the word if to begin our function. We will open up the parentheses, and then we want to tell the formula where to look. So I want it to be looking at the grade cell, which happens to be B3 in our case here. So if B3 is greater than 65, then we want it to say passing grade. And if it's not greater than 65, we want it to say failing grade. We're going to close our parentheses and click Enter. Let's see if it worked. We have a grade of 66, which is greater than 65, and we see that that's a passing grade. Let's copy this formula for the rest of our table. And that's how you use the if function. But what if we want to add more conditions? For example, what if we wanted all grades between 70 and 80 to be considered a C, between 80 and 90 to be considered a B, and between 90 and 100 to be considered an A? That's where nested ifs come in. A nested if function requires a great deal of thought to build correctly and ensure appropriate logic. It's used when you want to have additional results outside of just true or false. So let's use our data for an example. In our project, we want to create an if function to tell us if a U.S. state belongs to one of four regions, Northeast, South, Midwest, and West, and which of those regions it belongs to. In our data dictionary, we've been given the following information. If the state's code is 9, 23, 25, 33, and so on, then that region should be considered the Northeast. If the state code is 1, 5, 10, and so on, then that region should be considered South. If it's 18, 17, 19, 20, and so on, then that would be the Midwest. And if the code is 2, 4, 6, 8, and so on, then that region should be considered West. So let's use this information and begin building our nested if function. So let's begin by typing our nested if function in column D, our region column. So let's start the same way we did before. Equal sign, if, we're going to open our parentheses. So if our state code, which happens to be in column B here, so I'll click on B4, cell B4. If our state code happens to be 9, or our state code happens to be 23, or 25, or 33, or 34, or 36, or 42, or 44, or 50, then we want the if function to tell us that it is in the northeast. Now, did you hear how many times I said or between each of those states? It could be 9 or 23 or 25 and so on. So what we're actually going to do is add the word or to the if function to let the if function know that it could be one or any of the others here. So if, open parentheses, or. So let's double check that we're on the right track together. Your formula now should be equal sign, if, open parentheses, or, open parentheses, B4 equals 9, comma, space, B4 equals 23, comma, space, B4 equals 25, and so on through the rest of these numbers here. And then we want to have it return the word northeast for us. But we have more to do. What about the south region? So let's add that next. If, open parentheses, or, open parentheses, B4 is equal to, and I'm going to actually take the numbers from our data dictionary to make it a bit easier for me. So if B4 is equal to 1, 5, 10, 11, 12, 13, 21, 22, 24, 28, 37, 40, 45, 47, 48, 51, and 54. Then we want that to be considered the south. Now I want you to pause this video and try this with the rest of your data for the Midwest and West. You'll have a much longer formula at that point, and then you can come back, press play, and check it against my answer. Okay, welcome back. If you correctly coded your if formula here, then this is what it should look like. We have the line for the northeast up here and all the different state codes that align with the northeast based on our data dictionary. We have all of the different state codes that align with the south here on this line. We have all of the different state codes that align with the Midwest, and then the different state codes that align with the West. So now that we're approaching the end of our formula, what do we want the formula to say if our state code is none of the above? So what if it's not in the Northeast or the South or Midwest or West? What if it was possibly incorrectly added to the data set? So what we'll want it to say, if it's none of the above, is unknown, so that it's telling us that we might not know where it is right now. So we'll put that in quotation marks, and then what you can do is count the number of open parentheses that you have and match it with your closing parentheses at the end of this formula. So here you can see that these original open parentheses that start our formulas have not yet been closed at the end of any of these lines. So I'm going to count them. There's 1, 2, 3, and 4. So I'm going to close this formula with 4 parentheses and click Enter. And now we have the code to tell us the region of our state. You can then take that formula and copy it through the rest of your cells, as I have done already. And you can see now that the region is made up of 4 different values: Northeast, Midwest, South, and West. And we got lucky and there were no unknowns. So you did it. You just built a nested if function. With your nested if function, you were able to create a column based on multiple criteria, all in one formula. What else can you do with nested if functions within our data? Take a look at column E, which is the birth year. Maybe you want to group birth years together and create some sort of age bracket. I think your task 12 actually uses age groups in this project, so keep that in mind when you are completing that task. So to recap, the basic if function checks one condition and returns different results for true or false. Nested ifs let you handle multiple conditions, but be careful, they can get a bit complex with many layers. Thanks for following along with this mini lesson, and good luck with the rest of your project.
Welcome back to milestone number 4. You've just learned about supplementing data with a video from our NSDC project member, Emily. Before we close out this huge, big milestone, take some time here to review some final resources that we want to share with you. I've provided a couple links to materials about managing and analyzing open-ended data. Lots of really good information here. And I've also put some final information at the bottom about the ethics of data cleaning. We talked about that a little bit when we discussed outliers. We also talked about it when we were sharing how Mateo, your colleague, has removed null values, right? So cleaning is important and ethics come into the cleaning process as well. When you have finished all of this, you will be done with milestone 4. This was a huge and really important milestone in the DRM project. We've given you a ton of information, but you should now feel a little bit more confident in your ability to interpret and begin analysis of this raw data set. You're now experienced in working with raw data. You have a baseline understanding of how the variables in your data are represented, how they relate to one another, how they can be explained with the data dictionary. And so next time in milestone number 5, we're going to get into the essentials of your data. We're going to do some exploratory data analysis. Great job. Come back when you've had a little bit of a break and we'll dive into milestone number 5. See you in a bit.